Okay, good morning everyone again. Welcome to our first pre-training session for the Women Data Science Maastricht Datathon 2022. So I will be your one of the speakers for today. First of all, I would like to give a brief introduction for the pre-training sessions. So today will be the first one, and then tomorrow will be the second one. And those pre-training sessions are particularly targeting at people who don't have experience, a background about data science, or very limited background or experience. So if you're intermediate level or advanced level, I would also recommend you to join this session. But I am confident that you know how to do basic analysis. So today, I will give very low level entrance. So make sure everyone can start and. So today, the first day, I will give you an introduction about the data challenge, like a background about climate change, about energy consumption, and those kind of things. And then my colleague Marianne will lead you to go through Kaggle. For the people who never use the Kaggle, please pay attention. You will need to create an account. All your activity will happen on Kaggle, and Kaggle is one of the most popular machine learning or data science community used tools. So I would highly recommend you to know how to use Kaggle, because that will be very useful not only for this event but for the future if you want to have a data science practice or projects in the future. And then I will give you a like notebook, like pipeline about the data analysis on the data challenge, because we want to provide all the participants a interesting start. So we also give this a basic pipeline notebook. So we're going to make sure everyone will know, will be able to run some analysis, run the notebook, and to get some results. Yeah. So I hope you won't struggle with the programming part. But of course, if you do or you have any other questions, please ask your coach or tutor during the event. Oh, and then tomorrow we will have the second session. Then this tomorrow session will be more advanced. So for the people who already know, after today you will know the whole basic pipeline. But then for each step, you need to improve each step, and then to be able to optimize your results. So all the steps will be elaborated tomorrow in any more advanced methods. And so after today, you will know how to do it. Tomorrow, you will know how to do it better. So for the Women Data Science Data Challenge for 2022, the goal is to address an important way to mitigate the effects of climate change with a focus on energy efficiency. And you will analyze differences in building energy efficiency, creating models to predict building energy consumption. You will use a dataset consisting of variables that describe building characteristics and climate and the weather variables for regions in which the buildings are located. So those are the key information about this data challenge. Basically, this tells you why you are doing this, what you will do, and how you're going to do it. Those key features, I think, is generally all important for all the things in our life. But I want to say that if you want to be a data scientist, or if you want to do data science projects, I think, at least for me, those things are very important. I need to know why I'm doing this, the significance of this project, and what I will do, and what data set I will get, and how I'm gonna solve that problem, right? So this background introduction, I will focus on the words. As you can see, the climate change, energy efficiency, building energy consumption, and building characteristics, and climate and weather variables. I will explain the background based on those keywords. So first of all, when I look at this challenge, I had a question like, okay, it's climate change. I have heard these words for like years. I know it is important, but how much important to me or to our life? So I did some research, and then I think if you live in Europe, or like at least if you live in Netherlands, you could kind of like notice the weather changes and how that affects our life. So I did some literature review and some report reading, but today the background will be a little bit European driven. So the resources I got is more from Europe. First, climate change costs lives and money. So the average temperature in Europe has risen sharply over the past 40 years. So from the European Environment Council, they give a report about the average temperature in Europe has been increased 2.2 degree, as you can see. And then 2020 was Europe's warmest year to date. And then climate change causes extreme weather. I think everyone would notice this. For instance, the number of the floods. Like last year, I am living in Vermont, so it's the south of Netherlands. And if you're living in Maastricht, so this area, I think everyone remembers that what happened a few months ago, like last year, there was like a big flood, really serious flooding in the whole area, like in the south of Netherlands, and also in Germany and Belgium. As you can see from the statistics, they're like 22% increasing. The intensity of the rainfall over the last 50 years in the region is like increasing a lot. And third one is people are dying because of the extreme weather. That is serious. For instance, we can see from the Europe, between 1980 to 2019, over 85,000 people died because of the extreme weathers. And of course, climate change also leads to economic losses. Like if the extreme weather destroy the buildings, destroy the city construction, we need to rebuild them. People die from it. We need to save their life, and all those cost money. However, the good thing is that human action can change the course of events. So immediate, rapid, and large-scale reductions in greenhouse gas emissions and reaching net zero CO2 emissions have the potential to limit climate change and its effects. So it's from European Council, which telling us it is something that we can save the situation. And from this text, we learned that the reduction in greenhouse gas is one of the ways. And to reduce the greenhouse gas emissions, we can do from electricity system. Those are actually the area, the categories that generates those greenhouse gas. So if we want to reduce them, we can look at those categories and then to decide. Well, all of them need to reduce, right? From electricity systems, transportations, residential and commercial, and industry, agriculture, and land use. So from this picture, I move myself a bit. So from this graph, you can see by time we are trying to reduce the emissions by year. And then I want to mention that for this Datathon, what we are doing is building energy consumption, right? Which is actually in the category of residentials and commercial. I think it's from this line. They use too many colors, and then I was a bit confused at the beginning. Where's the residential and commercial category? And as you can see that after 2014 around, it's increasing again, right? So from the International Energy Agency report, that the building, for instance, from the construction to the use, the whole life cycle of the buildings are responsible for 37% of the global energy-related and process-related CO2 emissions in 2020, which actually indicates that the life cycle of buildings are one of the main contributors to the greenhouse gas emissions, which is negatively impacting climate change. So the home and the commercial buildings use large amount of energy for heating, cooling, lighting, and other functions. So anything you use at home by the electricity, they generate greenhouse gas emissions, right? Then green building techniques, and this retrofits means reconstruct the building, can allow new and existing buildings to use less energy to accomplish the same functions, leading to fewer greenhouse gas emissions. And then the techniques to improve building energy efficiency include better insulation, more energy efficient heating, cooling, ventilations, and refrigeration systems, passive heating and lighting to take advantage of sunlight, and the purchase of energy efficient appliances and electronics will positively impact the building energy consumption, and then it's good for the climate change. Well, slow down the climate change, let's say. So I think we all notice when you buy all the electricity stuff for your home, you have this level from 1 to F to G, whatever. So they all indicate that how you can reduce the building energy consumption. And okay, we already know where this building energy consumption contributes to the climate change. And we also know how those greenhouse gas emissions from the buildings are generated from heating, cooling, ventilation, right? But then why we want to accurately predict building energy demand or supply? So an accurate prediction on the building energy demand can prevent, for example, power shortage in cities. You know how much you're going to consume as a city or as a household. Then you buy or you plan the amount of the electricity you're going to use. Also reduce social costs caused by unnecessary energy supply that you buy while you generate more than you can use. Then that's waste of energy. And then support stable and efficient power grid operations. That's the whole city level planning. But lastly, I want to emphasize this: make impactful mitigation strategies. So the accurately predict building energy demand will make the mitigation strategies more effectively, because those things need to be planned. Policymakers or the people who make plan, well, policymakers, the people who works in the government for the environment, they need to know the energy forecasting, right? They need to know what will happen for the energy part, and they need to plan that. Everything need to coordinate with each other. that's very complex. The whole energy system is a very complex system. So if you want to know about building energy prediction or demand or supply energy forecasting, you are welcome to read those papers. This is not a new topic, so I provide, like, for instance, the review papers, like survey papers. If you're interested in this research topic, or generally you are just curious about that, I would highly recommend you to read those survey papers. They're very they kind of like summarize the field. And just some background knowledge about the prediction. You can also call it energy forecasting. There are 4 different type of forecasting. They categorize them into very short term, medium term, and long term. So our Datathon is in this medium term, because the data we got is 6 years building energy consumption, and then we want to predict the 7th year, so 1 year later, which is between 2 weeks and 3 years. So that is medium term prediction. Different prediction, they emphasize in different parts. The importance of the models and what they want to get from the data is different. So that's why for the people who has that experts, I think it's important to know which term you are actually predicting. But just for your background knowledge, we are doing this medium-term energy forecasting. So let's have a glance at the data first. So the data set consists of like around 100K observations of building energy usage records, and the data is collected over 7 years. So you will get 6 years for the training, and then you predict the 7 years. And the data is from the US. And the data sets includes the building characteristics and weather data and energy uses, of course. Each row corresponds to a single building observed in a given year. Your task is to predict energy usage for each building given the characteristics of the building and the weather data for the location of the building. Yeah? Keywords from this description: 7 years. So you get 6 years, and then you predict 7 years. When I read this sentence, there's something in your mind should build it up. It's about time. So it is time series data. People might think, well, why it's different? I will give one example. For instance, time. I mean, in our general world, time is a dimension, right? So if you think about a typical data analysis about, let's say, health data analysis about a patient, then this patient has like age, gender, medication use, history, like family health history, everything. So that is, you can imagine one patient has those features. There's no time involved. But if a patient is getting treatment every month already for 3 years, then this patient will have treatment 1, treatment 2, treatment 3, treatment 4. So this feature will have, the features of this patient has a time involved. So the same feature has here. We have this here as well. So for the 7 years, there's a time logic in the dataset. Secondly, the dataset has 2 main group of features: the building characteristics and weather variables. You have to think why, for instance, why the data providers describe them separately, right? There are 2 groups of features would affect the energy use. Lastly, your task is to predict energy usage. From this predict energy usage, you kind of like know it's a regression prediction. So that is the way that I would say for the people who are doing data science, the information we will get by reading those texts. Yep. So I hope next time for our beginners, if you get a description about the data challenge, you can also do the same. When you catch the keywords, you already construct the structure of this data in your mind, and you know that, okay, what type of data is like image, text, is there any time series, a process involved, event activity, all those kind of things would automatically build in your mind by just reading a very brief description about the data. And then, of course, predict energy usage, as I mentioned, is not new, right? So the traditional way, let's say, the early way is to use parametric and statistical methods. I also provide references. You can read it's a book, but I highlight this chapter 7. So if you are curious or you want to learn, I really recommend to read that chapter. And then, of course, machine learning models started being evolved in energy prediction years ago already. For example, neural networks, because of time involved. So, and also the complexity of the data and then the model of energy consumption. Neural networks were used a lot in this field. And last method, well, I won't call it method, but it's like combination of the statistical and the machine learning models. Okay. If you want to learn more, you can also read this source. They also provide a very detailed description about the energy prediction, but their explanation is quite technical, so I would recommend people who have some background to read it. I provide some literatures on climate change, energy consumption here. I will share the slides in the Slack channel and also the Zoom call as well, so you can read those literatures if you are interested. And those are the energy consumption prediction using machine learning models. And my colleague Parveen recommend this book, Energy Economics, Concepts, Issues, Marks, and Governance, as very good reading for the energy prediction. Yeah, so I want to, this is the last for the background, but I want to just mention you are solving a critical and real climate change problem. So you need to learn the background knowledge. They are not only the numbers, they are not only the statistics, they have real life meanings. And please collaborate with your friends, colleagues, team members, participants in this event who have the domain knowledge and expertise. And then share knowledge, expertise, and resources with each other. Lastly, you need to build prediction models and keep improving your models. Next, I would give the floor to Marianne. She will introduce Kaggle and tell you how to create a Kaggle account, where to find our challenge, and how to start a notebook, and how to team up with your team members on Kaggle. Yeah. And lastly, I want to mention that if you register to our event, you don't need to register for the Global Weeks activity. We will share the registration with the global organizer, with Stanford organizer. So you don't need to double register, but if you already did, that's fine, no problem. But you do need a Kaggle account to be able to participate in this data challenge. Okay, then I will give the floor to Mariam.
And it's from 2017. It's a subsidiary of Google. there are several academic papers published by results of the competition in Kaggle, and some popular companies had a Kaggle competition for hiring, like Facebook and Airbnb. For example, Netflix prize was open competition for the best collaborative filtering algorithm to predict user ratings for films, and the grand prize for that was $1 million. If you doesn't have any background of Kaggle, you can find a detailed explanation on kaggle.com/docs. It is too much information, but very useful to start Kaggle. And also there are two other references here. You see Kaggle past solutions or winning solution of Kaggle competitions. There are all past competition there with their best solutions. Let's head on kaggle.com and see how we can register account if you don't already have any, and see how we can find competition and join competition. Also, we can see how we can submit our code, our result. So if you go to kaggle.com, there's a register button here. You can register via your Google account or your email address. I already have one. It's really a straightforward process. And after you created your account, you can edit your profile. You can add a picture, also which city you are. Also, there is another option for bio. I don't see it here. Let's sign in again from here. Okay, if I come here, yeah, you see here you can add your location, organization. Also, there is a bio section. You can add your bio here. How to find WIDS Datathon on Kaggle? There's a search box here. You can type WIDS Datathon 2022. And if you scroll down, you will find it here with this logo. So once you come here for the first time, there will be a button here, which is join competition. After that, you join competition. You can see these tabs. Overview tab contains all information about climate change background, and there is data sets explanation and also acknowledgement. In the evaluation tab, you can see what evaluation metrics is considered for this competition. It's root mean squared error, and you can find more detail here. This is more important. Submission format, it should be the CSV format, and more detail you can find here. And a very good part is a frequently asked question. You will find really good information here. I recommend you go this tab. And you can find timeline, tutorials, prizes, and more detail in each of these tabs. And in data tab, there is an overview, explanation of data. You can use this comment to download dataset using Kaggle API, or you can download from here. And also, if you click in on each dataset, you can see a preview. Yeah. let's go to code part. In this tab, you see others notebook shared with you. Also, you can create a new notebook from here. And yeah, you can scroll down and choose the language you are using. Currently, Kaggle supports Python and R. And there are another option, code help. You can search here what you need. For example, if you type CPU, there will it will provide some codes related to CPU. And here there is a save version. You can save your notebook here. There are other options like save and run, quick save. We can, and in advanced settings, we can choose whatever you prefer each time. And yeah, for writing code, you can create a cell by clicking on plus, and with clicking in this icon or run from here, you can run your notebook. And also you can share your notebook privately with your collaborator or also publicly. The things which is important here, I would like to mention, is that you are just allowed to submit 15 permission per day, 15 submissions per day. So you can also check it how many you have left. Let me go to other tab. So in discussion tab, you can find other participants' questions and read them or create your new topic. You need to verify your account and then you can write your question, and yeah. And in leaderboard, as you see, there are two parts: public leaderboard, also private leaderboard. In public leaderboard, you see the scoring according to just 51% of the test data, and later when competition ends, you can find final leaders based on other 49% of the test data. One important thing is rule sets. Please read all statements mentioned here. Some are so important. For example, you cannot log in with multiple accounts and submit from multiple accounts. This is not allowed. Also, submission limit is mentioned here, and competition deadline. All rules are here. When you want to join the competition, you should accept bonding with all rules, and then you can join. One thing about teams is first, the team name is as yours, as your Kaggle ID. You can change it and save. Also, you can request to merge with other people teams. So you just need to paste the name of the team here and request merge. And if other people accept your request, it will be showed here. And also, if other people want to send you some requests, you will see them here. And some other information is there are a lot of courses in Kaggle. They are free, and you can learn data science material there. I think this is all from my side.
Yeah.
Thank you.
Yeah, thank you, Marianne. Thank you for the introduction for the Kaggle. And I think she raised very good point that you need to read the rules, because you have to accept the rules when you join the competition. And there are rules like, for instance, whether you can use the data for other purpose. Okay, so for instance, last year was health data, and they indicate that you cannot use the data for other purpose, for your research or for any other educational reason. You can't use that data. But at Kaggle or in general data science field, we promote open science, open data concept. So you can access the data easily, but how you use that data is regulated. So it's not like I can download it, I can use whatever I want. No. So read the rules when you join the competition. And another thing is the team part. So as you know, we recommend you join this competition with a team. It's more fun, and then we learn it from each other. So when you have the team, after this session, you will team up with each other together, and then you think about a team name and then tell your tutor, and you need to use this name as your Kaggle name. So that is your unique identifier for your team. Okay, and next, we already like a little bit over time, I know, but I will just use 15 minutes to go through this basic data science pipeline to make sure that people who don't have data science background can still start working. So I share the pre-training day one notebook in the Zoom chat, and also Slack Datathon 2022 channel. So if you click the link, so something like kaggle.com Changsun 1025 and WIS 2022 Datathon Maastricht day one. So that link, you will enter a notebook, something like this. So for the participants, for the beginners, if you want to learn about the data science pipeline, or you don't know where to start, I highly recommend you open that page. Let me see any questions. Okay, I highly recommend you open that page, this notebook, and then run the code with me together. Okay. Can someone let me know, is the notebook public? Like, can you see it? Are you also on the same page with me?
Yes, we can see it.
Okay. But can you also access to the notebook or not? No. Oh yeah, I see. Okay. Yeah. I will just share it again. I think people probably missed that part. Everyone in the meeting. Yeah. So I think when you click that notebook, you will have something like this, what I'm seeing, or probably you have a button on the right side says copy and edit. You can click copy and edit. Then this notebook, my notebook, will become yours will exactly being copied, pasted in your account. And then you can also run it. And if you don't know how to do it now, it's totally fine. We're recording the session, and you can also do it later. So let's start it. For the beginning, those are the background for the people who missed the first session, so they can just read it. They don't need to go through the slides. Coding part, okay? So for, well, at least coding in Python or Jupyter Notebook, what we normally do is we import packages we need. And of course, during programming, you probably need extra packages. You will add it at the beginning of your code. So you see import math, import Seaborn, import scikit-learn. So those are the packages we're going to use in the upcoming sessions. You don't need to understand how they import it, but just let you know that we're going to use those packages and you need to import at the beginning. And those are the analysis or visualization needed part. And the second cell is for the interaction. So this is from IPy widgets. So it gives you an interaction on the notebook, which is very friendly for the new beginners, let's say. For running the cell, you can either click this triangle or on the top here, the triangle, or the triangle on the left side, or just shift enter, then it will compile the cell, compile the block here. So once you import the packages, what we need to do is load the data. And when you create a notebook under this computation, or you just use the same, like you copy and edit my notebook, the data set is already in the input file folder. So you don't need to upload the existing data set anymore. And this part of code is to read all the files in that input folder, which is here. And then what we gonna do is is to read the training data and test data to this notebook, okay? And when you run it, it's read it, and then people, well, you know, if you don't have experience with programming, you will think, oh, it's loaded, where's the data, right? So you're gonna check, first thing, the rows and columns from the loaded training and test data set. How we do it is dot shape. So with the dot shape method, so train is the training data set you already read in your notebook, and dot shape will return the number of rows and number of columns. So as you can see that we have 75,000 rows, 75 rows in the training data set and 9,000 rows in the test data set. And the features, so okay, so you all hear features, variables, attributes, columns, those terms, they all means the column in the data set. They all means the feature in the data set. So probably people use different words. I said it here. When you also do the searching on Google or whatever, when you read, people will use different terminologies, right? But then you should know that they're meaning the same thing. Okay, so I have a question for the audience that you see. We have 64 features in the training, but we have 63 in the testing data set. Why the test has one less than the training data set is a very simple question, but I just want to raise it. Aha, right, great. So the audience, yes, perfect. Very Correct. So I think people already answer in the chat. That is in the test data set, there's no target feature, right? So the reason is that you have a trained data set, your model will learn the non-information and predict this energy use. But in a test data set, you don't have the energy use. You need to predict that. Okay, so that's the reason why it's not the same size. And I see people ask question. Okay, I will answer that later for the chat. And then probably you want to have a glance at the data. Like that's normally I would do. It doesn't matter how much I know about this data set. I always will print a little bit to see whether the data set looks like the data I imagined, right? So what you do is you, by running this line of code, train.hat, this will show the first five, right? First five rows of the data set. And then in this case, it shows all the columns, but sometimes depends on the tools or the setting. Sometimes it only shows like a part of the features. So you probably see ... and then the others. So is probably just too many features. So they will hide some features when it does the plotting. So another tip, a shortcut tip is when you do common and uncommon, in Python you use this sign, hashtag, right? Yeah, hashtag. If you want to do a shortcut, is control / or on Mac is command /. So it's easy, quick way to do it. It's just a shortcut tip. So another question, but I won't ask here, but for you, because we already have participants answer that the training data, the test data set doesn't have the target feature. So the next step for you is to figure out what is the target feature. So which feature the training data set has, but test data set doesn't have, right? So we won't do it right now because we have very limited time, but this is the step you need to figure it out. Not always the case, the last feature is the target feature. That's somehow interesting thing that people put the target feature at the end of their data set, like as the last column. But in this case, it's not the last column, if I remember correctly. So find out what is the target feature. Next, we're gonna do the feature exploration. I see already people ask they don't have this file called add-dictionary.csv. Why I'm doing this? Because I copied the information from the Kaggle data page, and they give the column name and then description just on the web page. For me, it's just easy when I use the notebook and I want to know what this feature is, so I can see the description about that feature. So I collect that information and save it in this data dictionary CSV. And let me see, copy, no. I will share the file in the Slack, and then you can do add data. Ooh, can you actually? Oh, you can't. Okay, okay. So you can upload the data and then add to this add file folder. Of course, you can name it differently, name ABC, but then in the path here, you need to change. You need to have exactly the same path to your file as well. I will share this data dictionary file later, but this is not necessary. Okay, this is just for me to do the data feature exploration is easier. So I'm gonna show you how it works. Loading. Okay. So when you run this cell, you don't need to understand what it does on this cell, because I just want to give you a function that you can easily explore the features. When you run it, you will see this interactive thing block, and then you can select the features you want to know about what they are. For instance, the state factor, and then it all shows what this feature means. Okay, so this is just for you to understand all the features. It's not about analysis. We haven't started analysis. Yeah, and so I will share the data dictionary file after this presentation, but as I mentioned, it's not necessary for you to do to have this file or to do the same. Yeah. After you look at the features, a number of the features, and then the first thing you would ask yourself is, okay, so are they all numerical or are they all categorical data? They are different, right? So in this data set, what you can do the checking is you put the train as the training data set and .d types. And then this line of code will print all the types of the features, right? But those answers are automatically understood by pandas. So it's a package. So when you import the data set, they will automatically kind of like interpret the type of the data and then give you a guess, give you an answer. For instance, the year factor shows integer 64. And then the building class and the facility type, because they are the value or text, so they give you a guess is they probably object. So they are like text, categorical. I have a question here is when you see in this data set, you see the year of factor is integer 64 and ID, they have an ID, right? ID of each row also recognized as integer 64. And year built, like which year the building was built, I think here is interpreted as a float 64 type. My question is whether they are correct. Why it is important? Because when you do analysis, or let's say do the correlation matrix, you're going to plot those features, and those features are understood as numerical, and your model will learn a relation between ID with any other features. If you think that the ID could have a relationship with any other features in your data set, then you can just directly import the feature to the correlation matrix to calculate the correlations. Otherwise, you should think, okay, for instance, the year factor, or let's say the year built is the year when the building was built, probably let's say in 1965, in 1980. Whether the year should be understood as a number or it should be a category. Because if the feature is a number, which means 1965 is larger than 1964, right, mathematically. But if you treat it as a categorical, then they don't have this larger or smaller relation. They are different classes. So those are the things you should think about numerical and categorical types in your data set. And we won't go deep in this direction because tomorrow Yanni will give further explanation and how to do encoding thing for tomorrow. But today I want to raise that this is important to know that you have different type of features. And what I will just continue. I won't do anything on this data set. I won't add any optimization in the data set today's notebook. It just goes through every step, very basic, but you still can get the results, of course. So next step I do is I group the categorical and numerical features, right? As it shows 3 features, I group them together. I call them like categorical features, and the rest I call them numerical features. As I mentioned, that I didn't do any optimization. That's why I just take the ones that automatically understood by the pandas. Then here you get an option. Oh yeah, because I forgot to run this. Yeah, and then you get an option to plot the categorical features. So for instance, the state vector is which state the data set is from. And then from this is the training data set. So I'm plotting the training data set, okay? And then you can change the feature you want to plot. Yeah, the facility type has a lot of classes, so it takes a little bit, 2 seconds to plot it, longer than the others, but patient, and then we'll get the plot. This is just do the feature exploration, and you need to compare the train data set and the test data set. So here I only did the train. You can also plot the testing data set and to see the differences, right? Like whether they shows you the same ratio from the training and testing. I guess it's not the same because each year doesn't have to be the same, right? But it's a good, I mean, you should check it and then you should understand each different ratios, how different they are. And next, I also give you an option to explore the numerical features. So here you can plot the features by time, by each. For instance, here's the May mean temperature or August temperature. You can choose like any feature, numerical feature you want. Then it's easy for you to have a look and understand each feature. And then here is the distribution plot for numerical variables. This is not the distribution, this is just the value, and then you get the distribution for the numerical variables, and then you can multi-plotting them. So if I choose 4, let's say, and then it will plot me the 4 features, the distribution of these 4 features. And I want to mention the blue lines are the training data set, and then the red lines are red data set, the test data set. So you do see the distribution is slightly different, especially for this one, elevation, which is very different distribution. So those are the important thing you need to keep in mind when you build a model. When you get results like very, very low accuracy, then you should understand, okay, whether you use the feature that appear in 2 data sets, but they have totally different distribution. Yeah, so you're free to plot as many as you want, but if you plot more, then you take more time. But you just wait a little bit. It's reasonable time. It's not like take hours. Yeah. So after the looking at each features, I also give you an option to plot the correlations between features. So by this block, I choose the average temperature in each month, and then I plotting them. So what you can do is that you change the name for the features, and then you plot different, plot the features you want, the correlations. Here is important information now. You see, the main job, the main calculation is done by this line. It's called here is the data set, and then .corr, the correlation. So this is a function from scikit, from pandas, I think. Yeah, right, from pandas. And then the thing is that they offer you different methods for the correlation calculation. By default, they use the Pearson correlation, but they also offer Kandel and Spearman. You try, for instance, right now, we see this correlation, right? If I change another method, for instance, this one, Kandel, you will observe totally different, well, very different, not totally, but very different correlation plotting here. So it is important to know what method you are using, because correlation will be the evidence that when you pick the features, when you do the feature selections, your correlation metrics is important for you to make decision. And which method you use to calculate correlation, that's the key point. And for the beginners, this is a suggestion, not only for the correlation, but for all the methods you're going to use for coding, for at least coding in Python, is that many packages, they have default setting. For instance, if I don't put anything, this code still works, right? Because they have default setting. In this short line, they have like 6 or 7 parameters were set up by default. So you need to check what is the default setting. Like when you put code there, you should know what settings you are using and what options you can choose. So here is not only for this analysis, but for all the packages you're going to use for the analysis, you should know the default setting and what you are putting there. You need to understand the methods. And it's very easy search. Like for instance, I gave you the link here. You can check the correlation coding from this web page. But for all the packages, they have a documentation. Just Google it and then you can read. It's very well documented. So I will also give you something like to do, then you can try to plot different features or all the features from dataset. Please keep in mind that when you plot all the features, not all the labels will print out, because too limited space, they will only print several features. So, okay, next, after explore all the features, you're gonna check the missing values. You need to know the completeness of your data set. For this year, it's reasonable. Only have like 6 or 7 features has missing values, but it's always like standard thing you're gonna do. Just check the completeness of your data set and think how you deal with those missing values. The details about the missing values will be presented by Yenny tomorrow, but I would also recommend you to do some background or like a research searching today about the missing values, because what I did in this notebook is just I removed the columns that has more than 5% missing. So I only keep the valuable features that has 95% data values in their row. So other ways, like for instance, or you you remove the rows. There are different ways to do it, but I won't go details for today, because remove the missing values will have impact on the accuracy. But I won't go detail today. I removed the columns that has more than 5% missings. And then what we did next is encode the categorical and numerical features. So as I mentioned, that the detailed will be presented by Yanni tomorrow also for the encoding part. Today I would just use the very basic, simple one. So this is from scikit-learn. And if you want to know how this label encoder does, just search scikit-learn and plus this one, this line. Then you will find their documentation and you will read it. And then you can also see many other options to do it. I also, in this or normalize, and then by doing that, you have multiple ways to do that. And I give all the methods you can try. For instance, I use this standard scalar, and then you can also try the min, max, and the robust, and you can see how they're different and how they impact on the final results. So today I would just use the standard scalar, and this, basic one, but they are very different methods to do the standardization and normalization. So please read the documentation and then find the one that you think is reasonable. Oh. Let's see. Oh, I missed this one. So when you run a notebook, please make sure that all the cells are run in order. Otherwise, we'll goes error. Yeah. And then after the normalization, we also you can also do the outlier detection. It is not necessary in some data set, but you always want to check whether there's many or extreme outliers in your data set. So for more ratings, you can read this web page. They explain it very well. I didn't do any outlier detection and remove outliers in this notebook because I want you, if you're interested, I want yourself to try it out. And keep in mind that when you detect those outliers, whether you want to remove them, right? If you want to remove them, you can activate those two lines. If you don't want, then just don't do anything. Just check whether there's outliers or not. Okay, we head into the last step. If you run along with me, then you should be almost at the end of the notebook. So we did like 80% work on pre-processing, okay? Like checking the missing values, feature exploration, checking the missing values, encoding, and then normalization, and then detect outliers. And now the data is ready for you to build a model on. So first, you need to split your training data set to training data set and train. Well, it's complicated to explain. So you have a trained data set, and then when you build a model, you want to build a model on the non-information, and then test on the test data set, test on the other part. So normally you can just run this line and then decide how much you want to split your training data set. It can be like 20% to 80% or 25, 75. Normally it's 20 to 80. And the random states, you can change to any other number or says none. But normally I will keep these random states, use one number. Then I make sure that every time when I build a model, I got the same training and testing data set. So let's see here for today, like for the beginners, I just use this XGBoost, which is recommended by the previous competition participants. Before, this tool has like really good performance, but there's no model perform best for all data sets. So you can try other methods, of course. And as I mentioned that if you decide to use one one package, please check all the default setting, and you have a lot of freedom and a lot of options to try different parameters, the combination of those settings. But you need to understand what they mean, what the learning rate is, what is gamma here. So read the documentation about the model and then try different settings. Here, I build a model on this line and then feed the training and testing, feed the training data set there, and then predict on the testing data set from that train CSV. And then I choose the, yeah, this is the right order. Yeah, I choose the root mean square error as the evaluation metric. So if you see here, the last line of this block, I use this root mean square error, but there are actually many different evaluation metrics for regression. So just search on Google regression evaluation metrics and then see many other options and decide which one you want to use. Or I think like just check the document about this data challenge. They probably also require which one you're gonna use. But anyway, this is information about the evaluation, how to evaluate your model performance. It matters a lot how you evaluate it. So after training everything done, you want to use the model to predict the target feature in the testing CSV data, right? So this block, when you run this one, this line will predict on the testing data set and then generate a results file. So if you want to see how your results need to look like, it's something like this. You have an ID of each row, and then you have a predicted value for each row. And you submit. So after running this, you will see the output generated here. Then you need to submit this file to Kaggle competition. Then you will return, the Kaggle will return you a score at the end. So by running the whole notebook for the beginners, I hope you understand like the steps you did, and then you can submit the results to the Kaggle and see how your method performs. So even you don't have a background, you can try to run and change things based on this notebook and then see whether you improve the outcome. Okay. Okay. Any questions?